we are in the Weather Lab, and of course, we're very, very proud of this facility, and this is something we're just launching today. We are going to show you the anatomy of a tornado, okay? And think about this. We have all sorts of different sizes of tornadoes, right? You go from the funnel clouds and the weak tornadoes that you guys just showed to the F5 that hit Moore, Oklahoma on this date back in 2013. Horrible day. All right, let's talk about the anatomy of a tornado. It starts with a supercell, a rotating thunderstorm. But on these tornadoes, there is one thing that clearly stands out, especially when we look at radar. It is called a hook echo. And that hook echo is a little appendage on the southern flank of the storm. We know that these storms aren't flat. They're in the vertical, 40, 50, 60,000 feet. So let's pull this thing up and look at it. Because when you look at this big rotating thunderstorm, and as massive as it is, look at what's going on down here. Look at that tornado. So just a small part, but the most violent part of that supercell is right there in that tornado. So let's lift the base of this and talk a little bit about tornado genesis, because a lot of the research over the past several years has gone into what actually kicks off the tornado from the supercell. Well, there's one thing that stands out. You can sometimes see this when you're in the field. It is called the rear flank downdraft. It's when the upper level winds get caught in the downdraft, they come through the backside, and if that rear flank downdraft isn't super cold, it can actually allow a tornado form, especially when you have on the eastern side of that warm, moist air. So warm, moist air, cool outflow on the backside of that. You see the rotation going on, and voila, we've got ourselves a tornado. Preceding a tornado, there's another feature we have to talk about, and you saw it on the video that we just showed. It's a wall cloud. It's the base of the thunderstorm beginning to lower, tremendous violent motion. Sometimes these whole wall clouds are rotating. Sometimes you just see the air coming up into the wall cloud. But when the wall cloud starts to produce a funnel, and whether that funnel is on the ground or not as a tornado, the problem is when you see debris on the ground, you know you've got a tornado. And the debris cloud is the last place you want to be, because within that, you've got trees, you've got homes, you've got cars, and sometimes you have humans. And that debris, of course, is being rotated around the storm and is eventually centrifuged out. In some of the stronger tornadoes, we see common features right around that immediate funnel, and that is upward motion right on the outside of that tornado, followed by inward motion, sinking motion on the inside. This is an amazing feat of nature, and no country in the world has more tornadoes than the United States. We average 1,300 per year. Sam, Jen, Anna Rittis, that's more than 10 times any other country in the world.
Wow.